Hi everyone! In this video, I will show how I use SimScale to simulate wind conditions around a building and use that data to inform design decisions. As you can see, I created a project, name it, title it, describe it, what I'm going to do, microclimate simulation for building, and tag it as architecture and create it. For importing the 3D model, I created a simplified 3D model of the building. It's important to keep the geometry clean and not overlay detailed, because the goal here is to understand airflow, not model every architectural element. So I export it as STL, or you can export it as IGS. I preferred STL. We export the model, and then in the site we import the model. So after importing it, so it's important that to analyze climate data for the site to understand the wind direction and general conditions that you wanted to simulate. This helped me define the wind input for the simulation. So as you can see, this is the solid building and model that we imported in here. After importing the model into SimScale, I created an external flow volume. This generates a larger domain around the building, which represents the air that will simulate it. Then I set up the simulation using an incompressible flow model. On the geometry side, you can see we have two volumes, but we should only have one volume. As you can see, we have two geometry and two volumes, but we only need to have one volume, which is the air. So we are going to delete this from the toolbar. We are deleting the villa, so we only have the air flow. After that, we need to update the geometry part, which, as you can see, we only have the air, which this building, the solid building, is removed, and there is a negative part in it. The next part is adding material, which is air. This volume is the air, and for the boundary conditions, I define a velocity inlet, which is wind coming based on the wind direction and speed. So I defined 5 meters per second using the, for example, if the wind is coming from west to east, so the direction is like here, so we assign the phase in here as the left part of the building. But if the wind is coming from east to west, so the direction is -5, and we should assign the opposite side, the right side of the building. Then when we want to assign the pressure outlet, which is the wind leaving on the opposite side, again we should assign it on the box. The ground and building also represent as walls, so the air, there are obstacles for the flow of the air. This in here we should remove all the edge, all the surfaces that are defined as the air is coming and leaving from this area. So only walls are the obstacles that should be remain in here. As you can see, there are 9 surfaces inside this box that define as well. Once the setup was completed, I generated the mesh and ran the simulation. So we should generate it and wait for it to generate. And after that, the simulation runs. So this is the setup for the simulation, and for the community plan it only needs 10 simulation runs and you can start it. I have ran this simulation, and I will show you what was the result, the solution field. So on the solution field in post-processing, we need to change some of the settings. So as you can see, the position, the orientation should be on the Z, and you can see all the simulations. You can change the solid color. You can also use the vectors to show the wind arrows and direction. You can change the size of these arrows and other edit parts. So from the results, I could see that wind accelerates in certain areas around the building, which could lead to discomfort. Based on this, I introduced design strategies such as planting and buffers to reduce wind impact and improve outdoor comfort. This process helped me move from intuition to evidence-based design using simulation to support spatial decisions. Thank you for watching.